Graphing, looking at the period. So if we have y is equal to sine, and instead of just an x, we have a constant times that x, I wonder what it will do to our graph. Now the period, when we talk about period, it's where the interval repeats of what the graph looks like. So in this case, our case of sine of x, we can see that if we start at 0, at 2 pi, we see another repeat, and it's going to continually repeat. This section, this amount right here, is called the period. So it repeats after 2 pi. And we can find the period not even just looking at 0, but we could come over here and look at it over here to figure out when the graph repeats. So looking at this period, we know that y equals sine of x, it repeats after 2 pi. So it'll continue to go through that. And that's because as you go around the unit circle and you continue to go around again, this way, so as you go around again, you're going to hit those same height values as you go. So let's look at what happens if we change the period. So if we have, say, instead of y equals sine x, we have y equals sine of 2x. So at 0, we see it's going to be the same. So at 0, y of sine of x is just 0. And then 2 times x, 2 times that 0 is going to be 0, and sine of 0 is just 0. Then at pi over 4, let's look what's happening here. So at pi over 4, y equals sine of x, that's square root of 2 over 2. That's the height at that point, just looking at our unit circle. And then here, if we put in pi over 4, right here for our x, we have 2 times pi over 4. We're going to end up with the sine of pi over 2. So at pi over 4, this y is going to equal 1, or the sine of pi over 2, which is just 1. So at pi over 4, my new graph is going to be at 1. Pi over 4, I'm going to be at 1. At pi over 2, my y equals sine of x, I have a 1. Looking at that unit circle going all the way to the top, I have a 1. However, if I put it in here, y equals sine 2 times x, my x is pi over 2, I'm just going to get the sine of pi, which is 0. Then, if I go on to the next one, I have sine of 3 pi over 4. Sine of 3 pi over 4 is just rad 2 over 2. But if I multiply 3 pi over 4 by 2, I get 3 pi over 2, which is just negative 1. So I'm getting some different values here. And then take a look at this. If I put in a pi here, I know sine of pi is 0. So if I go all the way over 180 degrees or pi radians, I get 0. However, sine of 2 pi, I'm putting in a pi for x and I have 2 pi, is 0. And I can see I'm already starting to repeat 0, 1, 0, negative 1, 0. And here, 5 pi over 4, reducing that, putting that in here, pi over 4, that gives me 5 pi over 4, and I just get a 1. So I'm repeating already at pi. So looking at this, if I multiply this by something, I'm making it go through that cycle a little bit faster. And I can find what that cycle is just by dividing. So the period of my new function, y equals sine 2 of x, I just take the 2 pi, the normal period for sine, and I divide it by whatever that is, that b. So we can really see it right here when we have a pi over 2, and we have sine of 2 times pi over 2. We do that division because we're multiplying this on top, and we get sine of pi, which is just 0. So to find the period, I can just do 2 pi over whatever that value is. So then let's take a look at what this is going to look like. I'm going to have this sine wave, so this pattern is going to repeat in a period of pi instead of 2 pi if I'm given this y equals sine of 2x. So it looks like this, and that's just plotting my points. So I'm already up to 1, and then I'm back down, oops, and up again. And now see here, I've already repeated that whole section of sine. And I'm going to go to pi again. Oops. And see, I've repeated it twice in 2 pi. When my first sine, I would only repeat it once. And so my period here is pi. Now, what happens if we have a fraction? So I rewrote it in a different form just to kind of get you used to that form. F of theta is equal to sine of 1/2 theta. So my period here, instead of having that 2 that's going to divide it, I have 2 pi over 1/2 and I have 4 pi. That means the sine wave is going to repeat itself after 4 pi instead of the usual 2 pi. So when I'm doing this, when I'm making a graph, what I do is I take that sine wave and I divide it into 4 sections. So the first section right here, second, third, and fourth. And the first thing I do with the sine wave is I find my zeros. My zeros are going to be at the end of my period, the beginning of my period, and the very middle. Those are always going to be my zeros. So depending on where it ends, and the very beginning, and then I take the middle, and I know that's also going to be a 0. In between my zeros, I know I'm going to have a maximum and a minimum. So when I'm doing my graph, my first thing is to figure out what the period is. I divide it into 4 sections. I plot my zeros. I take in between, exactly half in between my zeros, and then I can plot my minimum and my maximum, and that's just has to do with my amplitude. My amplitude in this case is just 1. So I have 4 pi, I go all the way to 4 pi, I divide it into 4 sections, and I take the very beginning, plot a 0, the very end, plot a 0, and the middle, and I plot a 0. I know in between here I'm going to have my maximum going up, and in between here I'm going to have my minimum. And that's kind of how I think about graphing my sine wave. Oops. Going through my 0, and then I'm coming back up and doing the same thing again. And I can go ahead and go down here. And that's going to be my minimum. So right here you can see at 4 pi, I've done my whole sine wave, and then I'm starting again. Normally, in my normal sine wave without my period being changed, or my period just being 2 pi, here I would have done the whole sine wave. But in this case, it's kind of stretched it out a little bit. So it's stretched out to 4 pi. All right, so let's take a look at cosine of x. Cosine of x also has a period of 2 pi, but you're starting in a little bit different place. So you start up here at 1, and you end at 1, and then you're starting at 1 again. So it also starts repeating at 2 pi, but the shape is a little bit different. And so if we shifted it a little bit, we'd actually see that same sine wave, and we could calculate the period that way as well. But usually we start with where 0 is, and it has this nice shape. And it too can be divided into 4 sections, and I do that when I'm graphing cosine as well. So I take the period, which in this case is going to be 2 pi over 1, which is just 2 pi, and I divide it into sections. So I first start at my endpoints, and my endpoints are going to be my maximum. So that's my 1. In between my endpoints, I'm going to have my minimum. So I go right down the center, and I know that's going to be my minimum. So then if I take between the maximum and the min on this side, between the maximum and the min on this side, I know those are both going to be 0. And that's what I use to plot my period. So my period in this case is 2 pi, and it will just continue on there. So let's take a look at an example. So I have y is equal to cosine of 2x right here. So my period is 2 pi over 2, or just pi. So in pi, my cosine is going to do this same shape. So I'm looking at the same shape. I'm going to go to pi over here. This is my pi, and I'm going to divide my pi into 4 sections. My first section is where I start, and I start at the maximum value. At pi, I also start at the maximum value. Halfway between, in this case it's pi over 2, is going to be my minimum value of -1. And then halfway between my max and min, I have a 0, and halfway between my max and my min, I have a 0. And that's what I kind of use to graph one of my periods. And then you do the same thing from pi to 2 pi, because we have a whole nother section right here. We can see the period happen again, oops, right here. And so you're just repeating that. And you can even go on to the negative side. So let's put this all together. Whoa. So let's look at both amplitude and let's look at period, if we can get this to stay up for us. So here we have y is equal to 3 sine of 2/3 x. My amplitude in this case is 3. So I have a period change right here and my amplitude change. My period is actually going to be a stretch. So when this number is less than 1, you're going to see it's going to stretch the graph out a little bit. So I have 2 pi over 2/3. I just flip that fraction and the 2's make a 1. And I have 3 pi. So I know this section right here, my sign looks like this. That's 1 period. And it's going to look like this in 3 pi. Now it's a little bit tricky. I'm dividing that 3 pi into 4 sections. So each section will be 3 pi over 4, 3 pi into 4 sections. So I have my 4 sections here. I'm going to talk about what's going to be my middle. So I know with my sine curve, I'm going to have my ends at zeros and my middle at zeros. So here I have 3 pi. I divided it into my 3 pi over 4 sections, so my 3/4 pi sections. And I took the middle between 0 and 3 pi, that's 1.5 pi, or 3 pi over 2, that's the middle. I know these are going to be zeros. In between my zeros, halfway in between my 0, I have a minimum over here and a maximum up there. So I know kind of what that looks like. And then I can go ahead and plot it. And you could just count by 3/4 pi each time to find those values, or you could take the middle between those. You could take the average between those, or the mean. Okay, so I'm going to continue. I'm going to start here at my 0. I'm going to go up to my maximum, which is 1/4 of the way through. I'm going to go down to 0. Oops, that's not very good. I'm going to go back down to my minimum and back up to 0. So that's 1 period within 3 pi. And then I'm just going to continue up. And over here, I would just continue down just to continue my graph. And if I went to 6 pi, I would see another repeat of this sine curve. So you're just taking whatever the period and you're dividing it into 4 chunks, and that helps you graph. Okay, so now my board can fall.